Now, of course, there are the other methods, and wanted to give a quick highlight here of the TPS or transient plane source. So this is a quite a different style sensor. It's a double-sided design. It measures conductivity and also thermal diffusivity. Again, the big point here is that the ISO is one that we commonly see referenced on the technical data sheets. It has some advanced capabilities for not only kind of bulk materials, but also things like thin films, anisotropic samples, slabs, which are more thinner format, high K samples, CP utilities, and so on. So it's definitely, I would say, more of more of an advanced method to operate, but does carry some really nice capabilities across a variety of sample formats. And the example data that I want to share here is on some really novel materials. So these were carbon-based foils, um, pyrolytic graphite being shown here. And these represent some of the very high conductivity class of materials that exist on the market. The combination of high conductivity and thin format often present a challenge for your kind of more basic bulk mode or bulk style measurements. But again, with the TPS, with some of the advanced utilities, specifically the slab utility, it provides a path forward to be able to address these. So this was a collaboration. So HPMS Graphite provided the samples. We did some testing here. And as you can see, getting values upwards of 1800 watts per meter Kelvin is certainly, quite high. So again, whether you're testing solids, pastes, conductive thin samples, these different types of materials can introduce relevant considerations to which method is most appropriate. And of course, on the transient class of instrumentation, minimal sample prep, these are fast, non-destructive, that can accommodate quite a wide variety of TIM types. Oh, there goes that animation again. um, so, thermal conductivity and your setup. So compression. Like I said, over compressing a sample is something that can artificially inflate the value if that's not how it's intended to be used in application. This was some test data we collected on both a silicone and a non-silicone TIM using the TPS. Looking at, it's with respect to deflection here, kind of just another way of looking at your compressibility or your sample thickness. But as you increase essentially that applied force load, you're densifying that material, you can see how that thermal conductivity value can shift. So depending on which group we're looking at, this resulted in a 16 to 43% increase to that thermal conductivity value. So again, it's not that one, like this state or this state is better than the other. It's just ensuring that you are testing it in a way that's representative of that application. And again, on a technical data sheet, if not otherwise specified, you would expect for many of these contact-based measurements, there is some amount of applied force that is needed. Certain standards and areas will specify as maybe a minimum or a certain range that is required. But the more information you have, the better equipped you will be to make those decisions.